agenda. So let's try to keep like a normalized kind of slide for this every time we discuss any kind of pattern. So today we're going to talk about the sliding window pattern. It's sort of like a weird kind of pattern initially to look at it. Even like a lot of us, we have a lot of difficulties with it because to envision it, it's a little bit weird, but we're going to try and see how much we can sort of make it easier for all of us, right? So yeah, the sliding window pattern, and then we're gonna take a deep dive into one of the most common interview questions asked by a lot of big tech companies. It's the longest substring without repeating characters. We're going to talk about it a little bit, maybe look at a couple test cases. We're going to be mostly focused on approach a lot this time. And then we're going to code it up on REPL, and then maybe discuss any kind of next steps you can take, any kind of other problems you can look at, and then time for Q&A. Okay, so before we go in and start coding and everything like that, what is the sliding window pattern? Okay, imagine you have a sort of like empty space, and then you have a window, and then there's like two glass panes, and one is moving and one is fixed, and you're trying to do something like this. It's one of those GIFs that that took from the internet, literally explains what a sliding window is. So there you have it. It's plain and clear. So you notice that it's moving and everything, right? How would you let's think about if it's closed, or if it's like if there's an open space and then your windows are all like at the same point. So how would you make sure that you close the window? You actually close the block of open space, to close your window. So how do you do that, right? You would basically take the movable portion of it, of that, the thing that you're seeing there, and you're gonna like move it so that it expands. The closed portion would expand and your window would close. So let's just have that in mind, okay? And what other things do we have here? We have like a window that literally fits that open space, and then you have a window exactly for it. Let's also imagine that there's like a huge block of open space, and then you just have like one small like window that you can move around and stuff. You can't do much. You can't you don't have like a extremely long expandable window, we'll have that in mind for the future. For now, let's just have this in mind. Okay, again, to summarize, we have two parts. One is sort of fixed. We'll discuss more about the fixed nature of it in like a second or so, or maybe in the next slide or so. But one would be moving and one would be fixed. The fixed one would be at the start until you would sort of have to move the fixed portion as well, and we will get to that in a second. And then the moving one is where it would keep expanding and expanding. Okay, and then there's a stopping condition where we need to reassess what to do with both parts. Why is that sentence in there? So let's talk about the situation where there's like a lot of open space, and then you just have like a tiny movable, slidable kind of window. So in that case, if you're imagining that this is the open space and you're starting here and then you're moving until here and you're here, right? You still have this much of a portion to sort of cover. So then the fixed portion should also move. right? If the fixed portion was here, it should also move in order for you to reach the end of that open space or whatever. I'm trying my best to explain it in a weird kind of way. If it's like, if it's not too intuitive, let me know in the chat. So yeah, yeah, a good, I see a lot of nice comments on the chat there. Yeah, so now we would need to move the fixed part based on some kind of condition. Okay, what was the condition here when I was explaining with my various hand movements was that I reached the max length of that window to cover the open space. I needed to move this so that it reaches the end of that open space. Okay, so we've spoken way too much about these like windows and stuff. So do you have anything else? Did you have any other kind of like any other kind of thoughts or anything like that? Just let me know in the chat there. I think we've sort of like covered what we are seeing here. Okay, so far we were just looking at these windows. So based on that GIF, can we have like some kind of pattern or like something like that? Can we like derive some sort of way you can use this to solve a problem in an optimal way? So let's go. Okay. So like I was saying, there was that huge block of huge horizontal block of like open space, and you're trying to like move things around and stuff like that. So about it, it's some kind, let's do, it's not like a proper formal definition of this, what this is. It's just like a informal, let's just put it out, let's convert what we were saying before, and let's convert it into like a problem solving kind of phase. So we have some kind of like linear input, right? Like horizontal stuff. You can't, I'm not, I don't think you can use it with like trees and like weird, like nested kind of data structures, but linear kind of input would work. And then this window is composed by 2 pointers. So now we think, oh, okay, wait, 2 pointers. Yeah, it makes sense, right? Like you'd have one here, you'd have one here, and then you'd keep like moving them around here and there. So one is generally fixed, but it moves after window size is reached. And the second one, it just expands the window. And again, you have like that kind of condition or some restriction or something like that, where you'd know that, oh, wait, the fixed portion or the pointer at the start should move now, because you have like, you've reached or you've hit this kind of condition. Yeah, you can use it with a matrix problem too. Anything that sort of can be broken down into like a linear kind of input, because matrices are like 2D arrays. So yeah. Okay. So now what we did learn about 2 pointers before. So could you drop in the chat about what is different from the 2 pointer approach and this approach so far? Like, because we're saying there's this other like pointer that's like expanding, it's taking in all of the elements in the input, like, it's taking that entire chunk and you're going to process that chunk. And then 2 pointers, you were doing something else. So can you if possible, could you like drop down in chat what you think? Okay, 2 pointers needs to be sorted. Okay, yeah, that's a good one, but I'm talking more like a structural processing kind of way. With 2 pointers, how many elements do you process? And with at the same time, like you do some kind of comparisons, right? So with 2 pointers, what do you process? And with this window, what do you process? Like, yeah, I'm guessing that's, yeah. So if you have any kind of thoughts or something like that, I'm gonna wait like a couple seconds to actually talk about it. Oh, okay. Each pointer is gonna be n. Okay. So you're saying you would process at every point for the window. How much would you process if you have like exactly? Yeah. Good job, Ellen. Yeah. So with two pointers, you compare two things and then you move the pointer here and there based on whatever that particular condition is. With a sliding window, you get like a chunk. You look like a part within your data. If you have like a string, say a b c d e or something like that. If your fixed pointer is at A and your moving kind of pointer is at C, you would look at ABC. That entire chunk, you're going to look at it and do something with it or check something with it, basically. So that would be a slight like comparison between two pointers and sliding window. Yeah. So why like when could we use this kind of pattern or this kind of thing? Like I think for me this is completely like what was in my head when I thought about the when and why. I think if you have like a continuous like a stream of input that's coming along, if you have like I don't know like a bunch of integers, and then you're gonna have to find like a running average or something of it, maybe. Then that would mean you take if you have four elements, let's just say four elements for now, okay, and then you're sort of like figuring out how to you calculate the average of it, and then the next element comes in and the first element has to be dropped out because you would have like a fixed if you say I need like an average of let's say get me like the average of two elements at a time or something, then your window size is two, it's fixed. So you would all of the averages before that, all of the numbers before that wouldn't matter, and then you would keep moving that window size of two, you would keep moving it to the right. So it's like a and as more elements come in, you'd keep dropping the ones which were previously there, and then you'd keep moving closer. So for me, that was the first thing that struck me. And within LeetCode in general, you would also have like you would use this approach for a lot of like substring and subsequences kind of problems. If you could drop in chat, what is a substring and what is a subsequence, and like what is a sort of difference between the two of them? So if like there's just one difference between the two of them. So if you could like drop in chat, that would be great. Substring is a part of a string. So okay, yeah, a substring is continuous in that if you have, let's say, A, B, C, D, E, AB is a substring of A, B, C, D, E. Okay, and then a subsequence would be, it doesn't necessarily need to be right next to each other, right? For a subsequence, it could be it's anything within, it's a sequence, but it's within the string, but it doesn't have to be right next to each other. Yeah. Yeah. So, and it like Sneha's mentioning, it doesn't have to be the consecutive, it doesn't have to be consecutive elements, but it should be in that order. Okay, cool. Awesome. So now, so like sorry, I got like sort of stuck with that, but let's get back. So what other stuff, what other things does this do? Why would we need to use this over other kinds of like brute force solutions? This sort of avoids a lot of unnecessary processing within the list, in that if you're looking at any kind of problem that says longest substring or like longest subsequence or something like that, there would always be that step where you would find out all of the substrings and you do like a lot of unnecessary processing within it to do those kinds of things. And that would shoot up your time to exponential time. And then like, you don't really want that. You like, when you can sort of optimize, then there you optimize. And so this could help you reduce it from that kind of like shoot up to a linear time. So yeah. Okay. Oof, we're here now. So let's talk about this problem. It's the longest substring without repeating characters. Okay. So let's look at the problem statement first. Given a string S, you need to find the length of the longest substring without repeating characters, right? Okay, simple question. If you see this in some kind of like interview or something, you can be like, well, I mean, if this is the first time you would be looking at it, you would feel like this is a little bit better than looking at those like tree problems and stuff like that, right? So, but this could definitely lead you in the direction of using up a lot of time than those other kinds of problems that have like a difficult kind of problem statement, but are super simple if you look deep inside. But yeah, let's look at a couple of examples. If you have A, B, C, D, A, what is the length of what is the longest substring without repeating characters? Do you agree like that is okay? Yeah, true that. Yeah, matrices are like, oh, yeah. So that's so like if you look at it, you have what are the kinds of like substrings within this problem, within this ABCDA. A is a substring, AB is a substring, ABC is a substring, BCDA, everything, even like a single letter, all of them are substrings. So the maximum, the longest substring would be probably ABCD, or like you'd have like BCDA, and then the length, you just need to return the length for the output. That would be 4. So, oop, jumped way too quickly there. Yeah, so what is the for the next one, what is the longest substring, and what is the length of that longest substring? Mm-hmm. So longest substring without repeating characters, and what would be its length? Getting some answers, yeah. This would be, I'm asking for the second one, let me actually paste it in chat so that it doesn't, okay. So for this one, what is the longest, yeah. Awesome. Cool. So, okay, now that we have this problem statement, what kinds of, that's awesome. I see a lot of participation in the chat, pretty good. Cool. Yeah, so what kind of weird edge cases can this thing have, right? They're just saying it's a string S. So is there any kind of thing that we can ask? What kinds of questions would you ask? Empty string, okay. Empty string or string that yeah, case sensitive. Cool. When it's all the same, when you say all the same, do you mean like A, like, oh, okay. Yeah, cool. Got it. I think you can have like, okay, now let's talk about, I think you can have like the spaces and punctuation. Okay. So I think you can have like a, like all of those A's. I think that's valid. And then we could also have a length of string as 0, which is an empty string. And also this would include all of the it is not just lowercase or anything like that. It could have uppercase, it could have, like, it could even have like digits and like symbols and stuff like that, and also spaces. It's like, I guess, like it could have basically everything, but we need to make sure we only, I don't think, no, let's not do, yeah, we could do numbers, we could do like uppercase, lowercase. Let's make a solution that doesn't really care about case and everything. Let's keep in mind, let's think that it needs to sort of think about, your algorithm needs to have handling for everything, or it should be everything. Okay, a lot of good questions. Awesome. Okay, so let's talk about a brute force approach for this. So like we were talking before, if you have like the ABCDA kind of string, firstly you'd have to like go through that entire like string. Like you need to anchor at A. From A, you'll have initially both your you could start off a loop with one pointer at A, and then you could do like, you could with, how do I say this? So with the first pointer being anchored at the first position, find out all the substrings after that. So it'd be like A, B, ABC, ABCD, ABCD, A, and then for each substring that you see, this is just the first iteration. You don't even have to do all of these things. You just need to, like the last one, ABCDA, like you don't have to go through all of that. Let's do it for just because we're trying to understand why we're doing this and why the sliding window would help. Yeah, so so like with the first, with finding out each substring, we would sort of check if there are any duplicates in that substring or anything like that. If there are duplicates, we do not need to count that substring. We do not need to get the length of that substring. We need to keep in mind as we go on, we need to keep looking at the maximum length, right? Like, is your current length of that substring greater than your previous max length? And when I say current length of your substring, the one that is unique, okay, like a substring that is unique, is it greater than the previous one? You need to keep that in mind as well, because that's the answer you're going to return at the end. Okay, so that's what I meant here. So like, you compute all the substrings within the string. How do you do that? You like just the way we explain right now. Cool. So you loop through each substring, right? Like that's because how would you know if you need to get that length or not? So you need to loop through it entirely, check if it's unique. And if it is unique, then you get that length compared with the previous max length. And if the current length is greater, then you, whatever I said, I've written over there. And then you need to, when we say repeat till end of string, initially you would be at A, next you would move to B, and then from B you'd have to do B, BC, BCD, BCDA, like, all of the substrings within that, and then you'd have to keep doing it until the end of the string. Oof, seems like a lot of work to do. Let's see. So what do you think is the, with what we've discussed, it looks like we need to have one loop, one outermost loop that does like this kind of like where you see the where you see the pointer at A, the first pointer, it has like that. That would be like the outer loop, and then for that outer loop, you'd have like an inner loop that you know does like a if your pointer is at A, you're going to do A B, and then like A B C and all of that stuff. So the like the substring portion of it, there would be like another internal pointer that would be like another loop within it, and then once you get each substring, you'd have to check if there's like any unique kind of like if it's unique or not, or like all of that. So then that would be another pass, right? It would be a pass, one pass. In the worst case, if it's like the end, like if it's the length of the string, you'd have to go over the string once. So like if the substring is equal to the length of the actual string, then you'd have to go through like that full pass. So that also seems to be another one. So what do you think the time complexity of this brute force approach would be? Just drop it in the chat. And square, how so? Because we would do like an outer loop, and then we would do like another inside loop, and then within that you would do like another check for like within the substrings, like within each of the substrings. So let's say in the worst case, your substring equals the length of the string, right? So that would be another open. So like, so n cube seems to be it. Let me know if you don't agree with me there, because like we can discuss and see. So that outer loop, which does like the overall scanning, and then there would be like another inside loop for each element in the outer loop that would run n times. That would run until the end of the input, and then for each substring, and I'm saying the worst, and you have to remember in the worst case, it could be that the substring would be equal to the length of the entire string. So in that case, then that would be another event. So it'd be like a nested 3-loop kind of situation. And that would be equal to ov and cube in terms of time, I think. So if by any chance like there's like a if you feel like this doesn't work out, or if you have any other suggestions or anything, either after the session or like right now during the session, if it's after the session, drop it in the channel, so we'll talk about it there. Awesome. So in terms of space now, I think it's pretty negligible because you would just use some extra space when you're doing that kind of unique comparison check, because if we have like a character array and you're gonna like go over the substring, and for every character you see in the substring, you would okay, so yeah, n cube. Let's do that again, and then we'll talk about space again. So you have like this you would have like an outer loop that would sort of go over your entire string, and then within that outer loop, you would have like another loop that would sort of compute these kinds of substrings. So if you have let's say you have A, B, right? So next it would be this pointer, which is at B, it will move to C, and then it has to move to A. But the first pointer would be exactly where it is, and the second pointer would keep moving till the end of that input string. So for every since we're doing it for every kind of like for every element we're gonna go over, we're gonna do like a inner pass of O of n. Yeah, so we're gonna do like an inner pass of O of n. Again, the outer loop is O of n, so like you do like another inner pass of another O of n, and then because this is already O of n squared now, like because it's like you're looping through it twice. Now, why is it an O of n cube? If you take like if in the worst case, your first pointer is at A, and then your second pointer is at the end of the string, which is at A, that entire thing is also a substring. It's also a string, like it's that entire yeah, so like that entire thing, it could be, how do I say this? You would need to go over that entire thing um, to check if it's unique or not, because you would need to do like an entire pass over that substring. So because of that third pass, or like that third round, that would be another O of n. So that whole thing would be O of n cubed. I think like if it's if you have like a if you have like more questions, I think I'm going to do like maybe like a write-up of it or something. If you need it, let me know in the channel, or anything as well. Yeah, so we were talking about space as well, and we were also talking about it being super negligible, because we're just going to take some space um, when we're doing that kind of comparison. How do you compare? How do you see if something is unique or not? If that particular substring is unique or not? If we do like suppose you have ABC, let's do ABC A, and if you've heard of this kind of, you would see it a lot in LeetCode and like everywhere basically in problem solving. You would have like this character array, and this would be like you would basically get the ordinate value of that particular, if it's a lowercase a, what is the corresponding ASCII value of it, and then if it's an uppercase a, what is it? So you would find that particular value. I think I'm doing a poor way of explaining this, but yeah, so you would have like a character array which would basically which would count how many times your letter has appeared in the string. So yeah, so like thank you, Soumya. So yeah, so if you think of that would mean you would just store your extra space would just be like the character array, which is going to take the counts. If you see like an entry within that character array which is more than one, then it's a duplicate. That substring has a duplicate somewhere, and you don't want to put that. You don't want to get the length of that and store it in your results. But by this time, you would have already done all of the processing needed, and so the brute force is a bit weird that way, right? Thank you so much. Yeah. So okay, so now we're seeing that we're not really liking this, right? Why are we doing so much of? Why do we need to do so much when we can have like then we already know that we can have 2 pointers, and then we could move it around so that if you see any kind of duplicate or something like that, you could basically shift the pointer, the window to wherever you want it. Like, let's talk about it in detail in a second. For now, just play along with me. We'll talk about it. Okay, so I'm guessing, I'm hoping you sort of understood why, like, why this is so like long-winded and stuff like that. Okay. instead of using, yeah. So if you have like let's say you have like 26 letters, yeah, you do have 26 letters in the alphabet. Let's say you have like a lowercase 26 or something like that. You would sort of take the particular, this pattern, I learned it because I was doing a lot of these problems. You would sort of take whatever character you're looking at, and then you would subtract it from the ordinate of, maybe if you're doing lowercase, then ordinate of A. So ordinate of the letter A. So so now what you could do is you could just and once you get that, and if you like increment it by one, I think you'll have like counts of how many letters or like whatever you have within yeah, within that particular string. When you say character list, what do you exactly mean? Because like this one, it would just it would sort of define the index where you would need to increment by whatever count, and then at the end, if you, and then while you process, if you see like there's something that is like more than one or something, then you'll know it's not unique, and then you're gonna, okay, store the characters in a list as you see them. Yeah, you could also do it in a set, I think. But this kind of pattern is like, it seems sort of yeah, it just seemed to like strike me, I think. Okay. What will be the space complexity with ordinate? I don't think you need like I think that's constant. Do you mean like just the ordinate function, like the built-in ordinate function? I think that would be constant space, if I'm not mistaken. Good questions, guys. Like oh, with respect to this problem, okay. So as far as it goes, I think it's just going to be, because we're taking, what are we taking? We're taking lowercase letters, we're taking uppercase letters, and then we're doing numbers, right? So if you count all of that, I think it should be like 128 or so. It's constant space is what I think, or it could be the space. You could also name it in a different way maybe, but I don't think, because we don't have like a million alphabets or anything, or it's not gonna like increment like too badly, I'm thinking. So I'm guessing it's just yeah, I think it's pretty fixed. So okay, cool, let's go on. Okay. Okay, so because we did we miss anything? No, okay. Let's actually work on the problem right now. And before that, let me just take like a quick water break. Okay, we're hydrated, we're good to go. Cool. So let's look now. Karen, could you Karen or Soumya, could you
Hi.
drop in the REPL link in the chat?
Yes, give me a second. If you want to take a break, if you want to take a couple minute breaks, go ahead. I can help with settling, everyone settling down. And if anyone has any questions, feel free to ask us. Love the participation today. Very excited, very constructive. Everyone's learning. Love it, love it.
Awesome. Thank you, Soumya.
Okay, so guys, I just posed the REPL link on the chat. A couple quick things. When the second you get to the REPL link, we had a bit lag yesterday. So I mean the last section. So but this time when you get there, please fork it. Please use the fork function, which is located pretty much on the right top corner of the smaller window, so that this helps to create the own replicate, the own copy version on your own repo account, so that you can code along with us. So if you are staying on, if you're staying on, so Chethana will be sharing the live coding. So you can definitely code with us as well. So just remember to fork it before you guys start, like, editing. If you guys are able to edit, because we are definitely exploring repo. We love it. It's just a couple setting it could is missing, and then we want to like give it a chance again and try, and let's see if it works.
I'm going to zoom it in. When you say like, can everybody see it fine? Is it too big? Or?
I can see it clearly. Yeah, this is good. Huge.
It is huge, yeah. Cool, awesome. Everybody can see it.
All right, is everyone settling down before we move on? Just give us a B if you guys are good to go.
Awesome.
Thank you.
Loving this. Ooh, okay, guys. What were we? Yeah, so it's the usual stuff we have. Let me move this a little bit this way so that we can see our folder structure. From as per the last time, like all of us, we were transitioning together, and we did see a lot of server changes and stuff, and like all of us were a little bit like, oh no, what's happening? So this time we're trying this. So let us see if this works out, or we could change it a little bit more as per your feedback. Cool. So let's look at the first guy over here. Just ignore this. What I did was, from the last session to now, I just added in like some comments and stuff from the 2 pointers one. I'm not going to talk about it now, but just in case if you wanted to like see it or something like that, just added in some comments. Cool. So let's look at our current main. I've just imported in the file, and then just created like one test case. So if you had a couple more, please drop it in the chat so that we can test it out. And if it breaks, then we're learning new things, right? So yeah, cool. Okay, so we have two examples of the ones that we were discussing from before. And it's here we have like, why did I put in 5? Yeah, it's 6. Why did I put it in as 5? Great. So we have like the length of this is 3. The max, the longest substring without repeating characters, the length of that. I think the method name is super misleading. I will change it. So yeah, this is 3 and this is 6. We were talking about how weird the brute force one was. I put in like this kind of thing in case you're looking in the future and you're like, wait, what's happening? And like, I sort of forgot what this means. We have like this string, and then we're gonna, for each of the outer loop, each of this, we're gonna move this, right? We're gonna keep moving this, and this this ABCD, this would be like the substring, which you would check again for duplicate, yeah, for uniqueness or duplicates. And if you see any kind of duplicate, this doesn't have any duplicates, so we're fine here. And why is this 3? I have no idea what's up with me. Okay. So yeah, so now, so this is the sort of flow, just written in some substrings and stuff. If you want me to like like if you want me to do one more round of it or one more explanation of the brute force, let me know in the chat. Or we could just, if you're good to go, send me like a thumbs up or something. We'll do the sliding window part of it and then hopefully get to the coding portion. So are we good to go? Awesome. Everybody's excited for the sliding window. Awesome. Okay. Yeah. So now that purposefully left it like this because like we're gonna actually like try to see how to make this work. For each round, this is the string that we have, and we're going to find out what is like the maximum, what is like the longest substring, and whichever is unique, the length of it, we're going to return that. So if we start with, let's say both your both your I and J are, they're at the both your I and J are at the start, or like if you're starting off at the same time and you keep moving J. Oh, so you're going to continuously move J along, and you're going to keep checking if at any point you're going to keep checking, like initially the length would be 1. If you move your next pointer to B, your length would be 2, max length would be 2, and then this would be 3, and then here it would be 4, and then if you see another A here, it's already present. How do you know that it's already present as far as the sliding window goes? It's best to keep track of this with the help of a hash map. You could have like a, let's say you call it scene or something like that. You would have like a hash map that would keep track of when the character was first seen and its index. Okay, so if you come across a letter in your pointer, in your current pointer, where you're sort of like, okay, I've seen this before in scene, so what should I do now? So then you would your start pointer is here initially. So let's call this start, and then let's call this IE or something. Okay. If you move all the way to the end, you're here, and you see that this is already present in scene because it's actually like A0. I'm gonna write it as a set for now, but we need it. Okay, let me do it. Let me not be lazy. Let's do this. You're not lazy. Okay. 3, and then it's already present, right? Okay. So now what should we do, right? So this particular area of it, we should completely disregard now. We must sort of move our start pointer to wherever we are currently. Our start pointer should be it should be wherever this character was. You should remove that alone, and then it should be to the next index of it. So something like this. Again, I'm gonna explain this again. You're until here you're good because you have these 4 letters there, none of them are repeating and stuff. Now you get to this, this is already present here at this index. So now what we're going to do is we're going to, the one pointer that I said would be fixed all the time, and then you would just be moving one pointer along. For this, we would need to make sure that and then I also mentioned that there will be one condition where you would need to move the fixed pointer as well. So this is that condition where like you're seeing this kind of duplicate. So you would need to adjust your window to make sure that it doesn't have any kind of duplicates. If you look at this now, if you move your start, how do you move your start? because you already know that this is present in scene with the index. So that index +1 would be your current start, like where you should move your start. So your start would be here. It was here initially, now it's here. So if you look at this, do you have a duplicate? No, you don't. So this would also be like the length of this would be 4. For each iteration, for each round of this, you're going to keep track of you're going to keep track of your max length so that it doesn't like, you know, shoot up or anything like that. Okay. I don't know what I said, why I said that, but you get the gist. So this is a very, very like simple kind of example. Let's do this, right? Let's do this. We have this, and then we're gonna, yeah, A, B, C, D, A, yeah. Just a small difference, but we're gonna try. I cannot format properly at all. Great. So this is where your first pointer is. And initially your both your start and your like, you know, your I pointer, all of them would be at the same place. Your start is the one that is not going to move unless it hits that condition, and then you have to like adjust your window or whatever. That's the place where you move it. The I pointer is the one that keeps expanding. That would be like the general pattern of this kind of problem. Okay, so you're currently here, and then you're, let's say you're sort of like, yeah, let's say you're sort of here now. You're at AB, so far so good. B is not. Ooh, as we go, let's update scene. And if something's like not too clear or anything like that, if by any chance I don't get to it within this session, feel free to like message us or anything like that on Slack so that we can get this cleared up. Okay, so again, A0, now we're at B. This, so wherever your I is, that's basically where you would need to like update your, like, if your I is at B, you would need to update your scene hash map to make sure that you say that B is seen, right? So B is 1, and then let's move. Okay. You have C is 2, and then you now, yeah, now you have B, but B is already present. So now what should you do? Okay, because B is already present, where is it present? It's present here. So fine, let's move our start pointer to +1, right? Whatever that index was, +1, that's where you would move your start pointer to. So you have it here now. Okay, we still didn't get to A. We still did not get to A. So this is start, this is the start pointer, and this is the ith pointer, okay? And also, because we've seen this now, we would need to, yeah. So like, because of now that this entire thing is gone, how do we, what do we change our, yeah, what do we change our scene pointer to? The start pointer to, it would be here. And we would also update the, like, the scene map with wherever this current thing is present, right? So the 0, 1, 2, 3. Okay, so we've updated it. So far, fine. Now let's go to A. We're at A, but A is already present here. So as per our logic, should we set our start pointer to like B again, right? Like 0 + 1 B, right? Doesn't make sense. So we need to make sure, we also need to have like that other check in mind where your start, if your character isn't seen, the scene map, and like your start pointer is, should A be removed from the map? not really. You just need to keep updating the indices to the latest point where you saw that particular element, because simply just because you need to like the next time you see it, you would look at the previous one, wherever it was present, and then you would move it. Like, you wouldn't completely remove it from the map. You would just make sure that you update the latest position for that particular character in the map. Yeah. So as I was saying, would you move your start pointer to this again? No, you wouldn't do that, because we have like we need to make sure that only if your start pointer is sort of lesser than or equal to um, this value, wherever you saw that, right? Yeah, only if your start pointer is lesser than or equal to wherever you saw it, then you would then you would update your start pointer. Because like if your start pointer is already past that, like that particular index or anything like that, then you wouldn't worry about it. Like, you would just keep moving on. Yeah, so this is I think this is the crux of that problem. I'm going to see what, when you move the start pointer, you automatically move the I pointer to the, sorry about that. 1 second. My bottle does this really creaky kind of sound. Sorry about that. Yeah, so you automatically move the I pointer to the next element, irrespective of its length. Oh, okay. So while you forgot to mention, okay, so while you if your character is not in scene or anything like that, if it's good, so far it's good, we would keep incrementing our max length. So that is one part that we need to remember. How would we increment it? Or there would already be like a previous max length that we keep in store all of the time. And this it would be like the ith pointer minus the start pointer, like that particular substring plus one, like plus one, because like zero based index. But you would keep track of that every time you don't see you don't do any repositioning of the start pointer stuff. Like, if you don't see any like duplicate or something like that, you would keep incrementing your max length. I does this make sense? Or I feel like I missed another like message before it, or like, yeah. What I'm essentially saying is, if your character is present if it's present in your map, and then you're doing your whole like, moving the start pointer, then you wouldn't need to like keep track of the length. You would keep track of the length when you keep seeing these unique values, right? I mean, unique letters, or anything like that, unique characters. You would sort of keep incrementing your length. um, so at the end of it, you would have like your max length, because you would always keep comparing it with the previous length, and you would keep checking the most unique the substring within it. So and again, like each of this is a substring, right? You didn't need to do all of those like kind of long-winded processing stuff, because like now you can just like move based on what, if everything over here is unique. Let's see, A, B, D, G, and then it keeps going on. If all 26 characters, 26 letters are there, maybe lowercase ones, then that is your substring, and that is the max length. of like, non-repeating, like unique kind of characters. Okay. I think we've sort of like talked about this a little bit. Do you think, are you good if we try to code this up? I think the coding portion of it is just, it's not too like long-winded. I think I used long-winded so many times because I just remembered it. So, okay, cool. Okay, awesome. Let's start then. Let's first take care of our unique, like the case where the length of the string is, it's 0, right? So if in that case, what do we do? Okay, so if the length of, what is the, I think it's string. Yeah, string. If the length of your string equals 0, then you just return 0. Now what do we need to keep in track here? We need a couple of things, right? We have our start pointer that we were talking about so many times, that we need to keep track of that. And then while looping, it will take care, your I pointer would keep moving, so you don't have to worry about that. What is the other thing we need to remember? We need to have our hash map to store it. And again, like the most important other thing that we need to remember is the max length, because that's your result. And at the end, let's just say return. Ooh, I'm so sorry. Did you have any kind of? I'm so sorry. I get it. Like, is it too like? Did you have any specific questions or anything like that that I can answer? Maybe I'll be done in like 2 minutes. So.
Feifei, don't worry. It's not hard to take on if this is the first section. Everyone is following through, so you can definitely revisit our recording. If this is the first time you join us, remember to join us on the Slack channel. That's where we actually help everybody to answer the questions, discuss the problem. So it's okay to feel lost. Chana, you're doing fine. You're doing absolutely fine. Amazing. Feifei, if you want to catch up with us, definitely post ask some more questions, and we're happy to guide you through after the webinar on the Slack channel.
Yeah,
pass it back to you.
Yeah, so definitely, I'm so sorry. I understand, in general, if you look at this kind of thing, immediately it just trips you up. In all honesty, while preparing for the session, I was tripped up so much. I was like, oh no. And so we all go through that. So just definitely message us on the Slack channel or something like that, and then we can get things sorted. Awesome. Let's go. Okay, so we just put in our usual boilerplate stuff. Okay. With the start and scene, okay, so the scene is a hash map that we are going to store, where we're going to store all of the characters that we've already processed. So you have the start and the I pointers. The start pointer would be the start of your window. When you think about a window, that window would only have, suppose you're starting from here A to the let's see. Yeah, so you're starting from ABC, right? So your start pointer would be at A, and then your ith pointer would be at C. So ABC is the window, and your start would move to a different location if you come across a duplicate character. So we're going to talk about that a little bit we already we touched base on it. Let's actually look at it in the code. Okay, so let's loop, right? So for I, comma, let's use the enumerate one, because it helps to yeah. Thank you, Sneha. Awesome. So so enumerate would, it would give you the index and the character. It would give you the index basically. So let's do that. Okay, so you're enumerating the string. What is the first thing? What is the, let's handle duplicates here. Sorry, this is going on so long. If not, I talk a lot sometimes. If not duplicates, what do we do? And then update hash map, right? Only 3 important kind of steps. So how do you handle duplicates like we mentioned before? So if your character is in scene, and the second condition, you don't really like simply set the pointer to the you know, you would only set the start pointer to like scene of your character, like the value of that map +1 if your start pointer is lesser than or equal to scene of character. If this is it, then you would set start to be equal to scene of character +1. You would sort of remove, you would sort of move away from that duplicate character. You would move to the next one. Like in this case, if your start was here, scene would be 0, 0 + 1, B. So your start pointer would be at B. Okay, this is fine, I guess, for this. And if not, what do? We already have like the max length, right? So we're gonna keep updating. If this is unique, we're gonna keep updating our max length by max length, and then your I minus your start +1 because it's 0 based, right? You need to get the length which is in 0 based, so +1. And then after this is done, you would update your hash map. I have put in a lot of spaces in here, which I don't like. Scene of character equals I, because you need to remember this particular index for that character. It should be present within your hash map so that you can look at it the next time for this condition. And I think that's pretty much it for the problem of, I mean, for the problem. Okay, so let's see, what have we written here for this? We've written A, B, C, D, A. Okay. Yeah, so what would be the let me see what I actually, yeah, A, B, C, D, A is, yeah, it's 4. Okay, so do you think we're ready to go, or like did you have any kind of checks or something that we need to like incorporate looking at the chat? So yeah, if you're good to go, give me like a thumbs up and we'll move forward. Okay, so because like if you actually look at it now, basically you're just storing, because this is a string, you're just storing that particular string into like a hash map, and then you're basing it based on index. So you don't really have to worry about case sensitivity here, because you're taking, let's say you had like, I don't know, D or something like that. You would just store the index of this in here, and then what you would do is the next time when you look at the same D, like anywhere else, if you have like another D somewhere, then your start pointer would be GD like that. So it would cover, this would basically cover any kind of string. D, B, D. Okay, let's see. D, B, D. Oh, yeah. So even in here, okay, your start pointer is here. Your start point, I mean, your ith pointer is here, and then you see. Okay, Okay, I see what you mean there. Oh, yeah. Maybe I should have defined the problem better or something like that. Let's see. Okay, in this case, we would, yeah, they do. Yeah. Um, let me actually think about that and like get back to you. Because like maybe I should have defined the problem better or something, or I just said everything's okay. Yeah, yeah, we could do. Hmm. I'm just wondering, what if we were to think of each character as like, if they're case sensitive. um I'm wondering if I said if they're case sensitive or not. I think I was saying the input can accept anything lowercase or uppercase. That's what I was thinking. Okay. So if it is case sensitive, like if you find that out from your interviewer or something like that, then like, converting it to taking that string initially, and then just doing like I don't know, even in here you could do like I, I am forgetting. Maybe you could do it out here. Um, let me know in the chat. Could we do it directly in here? Could we change to lowercase in here? I think let's just do something like this, and then and then we could basically sort of put this in here. Yeah. So something like this, I think would be fine. Okay, yes for that. Yeah, I'm gonna do it this way, if that's okay. So let's just run it. We thought of 4 and we got 4, so that's cool, awesome. Did you? I think I think for now, let's just halt with the coding for now. If you have any more questions or like things that we could have covered but we didn't cover, I'm really sorry about like the case sensitive thing. I should have like been super um, vigilant about that, but sorry about that. Anyway, okay, so um, we're back to our slides again. What what would be like what would be like the next steps from here, right? This seemed like a pretty good kind of problem to actually see. Like this was a what we spoke about. This is a medium problem again. Um, I think from the next session onwards, I'm gonna. I think somebody left in a feedback last time. We could have done like um, okay, cool. Yeah, so I think somebody mentioned that if we leave in like an easy problem, it would be nice. So we're gonna probably try to leave in any kind of problem or something like that in the channel so that we can work on it together. So long as nice substring, a string S is nice if for every letter of the alphabet that S contains, it appears both in uppercase and lowercase. Okay. For example, ABB is nice because A and B appear, and B and B. Wow, I'm okay. Yeah. So given that, given the string return the longest substring of S, that is nice. Okay. If there are multiple, return the substring of the earliest occurrence. If there are none, return an empty string. I think this would be a really good starting point for us. Like if anybody wants to work on this like later on and like drop in a solution or something in the channel, let's do it. And also in LeetCode, every time you would have you would have similar problems below it, so similar questions. So like definitely like check those out in case you're struggling. It's best to like start off with easy problems and then go into this. Okay. Cool. We did quite a bit. Okay, so do you have any more questions or anything like that that we could look at, maybe? I'm gonna check. Karen, do we have any kind of questions?
I
And
think we
Joanne,
are
thank you
all
so much.
good.
Sorry about cutting you off. I was just like saying thanks to Joe. Like, yeah, thank you for like making sure like everything is that we're looking towards like a good, well-rounded solution. Awesome. Yeah, back to you, Karen.
Worries. So thank you. Thank you so much for Chandler for introducing us to the sliding window. I do remember you mentioned it could be a little tricky concept to digest if you are new for it. So for those who like a little bit lost, don't really worry about it. Like I mean, practice makes perfect. Just for the day, you guys to keep trying. Don't give yourself up if you don't know. But I see a lot of you actually really falling, trying to ask like very constructive questions. Is amazing section. Love to see this. And hopefully we can do it more. We will be doing it more the next two like next section. I will be updating all the slide materials, including the actual LeetCode link if you haven't seen it yet. On the Women Who Code channel, but I will definitely update you guys when it's done on the section. Also, remember to join us. Definitely encourage you guys to answer, post questions and like help each other out to figure out the problem as well. So yeah, I think that's about it.
Yeah, and if for some reason we don't get to you immediately, it's because like probably we're like stuck doing like other
Yeah.
stuff. So
Yes.
we
Give
will
us a little
definitely,
time. Yes.
yeah, maybe until that weekend or something like that, like because like the weekdays are super like hectic generally.
Yeah.
So just give us until that weekend so that we can like figure things out and like get back to you. And like a couple other like links as usual are like the study group repo,
Yeah.
and then the REPL link and stuff. Yeah.
Yes. 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 If you should join us, so we will be doing next week. Next lecture we'll be doing binary search. Woohoo! And then we might be posting some. You guys want to get yourself ready, warm up with the easy questions. Like definitely more welcome to do so. To share like thought like that would be even better on the channel. So yeah, and then remember to join us for the Connect as well on the 18 and 19 of and then get your 50% off for the early bird special using the Women in Code Python. And we do have amazing library series keep going on the oncoming Saturday and the next couple of Saturday as well. So if you want to explore more library with us, feel free to join us. Somia here will be definitely will be leading the session this Saturday for sure. Yay!
Awesome. So yeah, I'm so slow that I'm trying to type that talk. But yeah, thank you so much everybody for joining us. And like, yeah, if any questions, just message us, Slack us, etc. So yeah, really, really awesome session and love the participation.